Today, we will explore how arrays work, how they are represented in memory, and how strings in C are simply array of characters. Let us begin by understanding the basics of arrays. Arrays are the way to store multiple values of the same type under one name. They occupy contiguous memory locations, which makes them efficient for indexing. In C, indexing always starts from 0 and ends at size minus 1. However, unlike some other languages, C does not perform bounds checking. So accessing invalid indexes can cause memory issues. Declaring an array in C is straightforward. For example, int array 10. This allocates memory for 10 integers. In contrast, languages like Java use dynamic allocation with new. It is important to remember that arrays in C are fixed in size once declared. Every element in an array occupies equal memory space. For example, if we declare int a array size of 3 and each integer is 4 bytes, the total memory occupied will be 12 bytes. The total size of an array is calculated as the number of elements multiplied by the size of each element. We can use the size of operator to determine the memory size of an array. Size of array of I gives the size of single element, while size of array gives the total size in bytes. For instance, if we declare an array of 10 integers and each integer takes 4 bytes, the total size will be 40 bytes. Multi-dimensional arrays. C also supports multi-dimensional arrays like matrices. Two-dimensional array is declared as int matrix array size of 2 and array size of 3. These are stored in a row major order, meaning rows are stored one after another in memory. But remember, C still does not check bounds, so invalid indexing can lead to errors. Variable length arrays. With the C99 standard, C introduced variable length arrays. These can be declared inside functions with sizes determined at runtime. For example, int array size of n inside a function allows flexibility. However, global arrays must still have a fixed size at compile time. Memory is usually divided into byte-sized cells, which are the smallest addressable units. A word is the largest unit of the memory that can be accessed in a single machine instruction. On many systems, the word size is 8 bytes, which corresponds to the size of a long variable in C. In C, strings are essentially array of characters. What makes them special is that they are terminated by a null character written as /0. For example, the string hello is stored as HELLO/0. The null character indicates the end of the string. Since strings in C do not store their length, we must compute it manually. The standard library function strlen does exactly this. It loops through the string until it finds the null terminator and returns the number of characters before it. This is why string handling in C requires extra care compared to any other programming languages.